The worksheet you picked up in class today says equation practice, and these are the problems from either the practice test or the two versions of the solubility rule quiz that we did the other day. We will have another quiz like this on Tuesday when we get back after this weekend. So studying this is going to be in lieu of doing the extra session. So what we have here is that there are 9 problems in this. So what I'd like you to do is to watch and do the first 3 here with me, and so you really get a feeling for what's going on, and also study your ions and study your solubility rules, and then try the other 6 problems and then watch the video real quickly. Those I will go through very, very fast. So what you're trying to do is write the balanced net equation for each reaction. Now I did see this little image online, and it's kind of talking about the idea that there are some substances that are always soluble, and you should know about those, nitrates and ammoniums and all the alkali metals. And down here in the bottom, there are things that are always precipitates, carbonates and hydroxides, except for when they go with the alkali metals on top. And then there's a whole group of the ones in the middle, like the sulfates or the chlorides or the fluorides, where you have to learn the exceptions. So study your solubility rules, study your ions, and then try these first 3 problems, come back and try the other 6. Now, if on the quizzes you were doing really well, then you kind of know for yourself, how much of this tutorial you need to watch. This first problem, hydrogen sulfide gas is bubbled through a solution of silver nitrate. So the first thing, hydrogen sulfide gas, because we know hydrogen forms H1 and sulfide is 2-, the compound is going to be H2S. The other compound is a solution of silver nitrate, so we'll say AgNO3. And if we have a positive negative ion and a positive negative ion, then the first thing we should try is putting the positive ion here with the negative ion here. Now, because we know H is H plus and NO3 is NO3 we're going to form HNO3. And we have 2 H's, so we're going to need to have 2 HNO3s, and I put those in right away. Now, the other ions that can go together are silver and sulfide. So I always put my positive ion first, so it would be Ag2. S. Now that's just to get my rough version. This is the molecular equation. Now we want to look at and say, okay, H2S, that is a gas, so we are going to leave that totally as is. And nitrate, we're going to separate those into ions. Strong acid, HNO3, we're going to separate those into ions. And our silver sulfide, sulfides are almost always insoluble, so that's going to be our precipitate. So keep this one together, keep this one together. Now our next step then, we're going to say H2S plus, now split this up into 2 Ag pluses and 2 NO3 minuses. The HNO3, split that up into 2 H pluses, 2 NO3 minuses, and then the last compound, Ag2S, stays together as the solid. Now we look at this and say, do we have any spectators? Okay, the spectators are either going to be this guy or this guy. Okay, so look for those. And we see there's nitrates, so those cancel out. So what we have is our final answer. I'll put it down here, H2S plus 2Ag plus turns into 2H plus and Ag2S. Now on the AP test, we don't need to put in solids or gases or liquids, any kind of a indication of the phase. And if you do write them in, I think those are ignored. Okay, we should double check. This side here is 2 positive. This side is 2 positive. Okay, we have 2 silvers, 1 sulfur, 2 H's. So this is going to get us full credit on this problem. Now we're going on to number 2. Okay, number 2, we have a solution of calcium hydroxide. Okay, so that's a solution. Ca2 plus, 2 OH minuses, so CaOH taken twice. And since it's a solution, we are going to go break that up a little bit later. Okay, goes with a solution of magnesium chloride. We know magnesium is 2 plus, chloride is 1 minus, so it's MgCl2. Now again, we know that chlorides are soluble, except for silver, lead, and mercurous, so we know that's going to be a soluble compound. We're going to change partners on these two. we're going to have calcium chloride, so CaCl2, and magnesium hydroxide. And again, we know that chlorides are soluble except for silver, lead, and mercurous, APH. So that means this guy better be a precipitate. We need something to drive this reaction. And we know that hydroxides are usually not soluble except for the alkali metals in calcium, barium, strontium. So magnesium hydroxide, that will definitely be a precipitate. And we should also remember that that is milk of magnesia. Now we're going to go back and split things up in ions. So we have Ca2 plus and 2 OH minuses. We have Mg2 plus and 2 Cl minuses. Ca2 plus, 2 Cl minuses, and then MgOH taken twice. Now we're going to go through, do we have any spectators? Okay, calcium, spectator. Chloride is a spectator. So the final answer would be magnesium ion. I always like to write my positive ion first. Plus 2 hydroxide ions turns into MgOH taken twice. We're going to take a moment and double check and see, is everything balanced? We have 2 plus, we have 2 minuses. So on the left side here, that's going to be neutral. The right side is neutral. We got a magnesium, magnesium, 2 oxygens, 2 hydrogens. Okay, this is going to get us full credit. Number 3, sulfuric acid. Sulfuric acid, H2SO4. And that's a strong acid, so when we get to the ionic step, that's going to be broken up. Okay, we have barium acetate. And we know barium is 2 plus. And we know acetate is 1 minus, C2H3O2 minus. So we need 2 of those. So we're going to change partners. So we have H and C2H3O2. Now we should recognize that that's acetic acid. That's a weak acid. So that is actually going to stay together. It's soluble, but it doesn't break up into very many ions. So it's mostly together, we write it together. I skipped this one. All acetate compounds are soluble. And before I forget, I have 2 H's and I have 2 acetates. So I'm going to have 2 acetic acids. Now the barium and the sulfate go together. We know that sulfates are soluble except for calcium, barium, and strontium. So that one is going to stay together. So our next step here, we're going to have 2 H pluses. We're going to have a sulfate ion, SO4 2 minus. We have a barium ion. We have 2 acetates. We're going to put together, we're going to get 2 acetic acids and a barium sulfate. Now, since we haven't even broken up any ions on the right, there are no spectator ions, so this entire equation is our final answer. Now we should double check and see, do we have any over here, is everything balanced? 2 H's, we got 2 H's, we have 2 acetates, 2 acetates. Oh, I left a negative sign off, I would have lost points. Barium sulfate, Ba2 plus, SO4 2 minus. So the left side, all the charges balance out, the right side is neutral. This is going to get us full credit. I'm glad I noticed my little negative sign missing. Okay, so I'd like to stop here, have you go through and try all the other problems before you come back here. And we are going to go on to the other problems now, and those are going to go kind of quickly. So for number 4, a solution of lead nitrate. So lead nitrate, so I say lead is 2 plus and nitrate's 1 minus, so we get PbNO3 taken twice. K plus and I minus, we get Ki. And to balance that, we're going to put Pb with the I2 and the K with the NO3. We need 2 of those. Going through now, looking at it, nitrates are always soluble, so that gets broken up. Potassium compounds are always soluble. Now we know our solubility rules. We know that chloride, bromide, and iodide are soluble except for APH, and the P is lead, so we have right there. And potassium compounds and nitrate compounds are soluble, so that one definitely breaks into ions. So we have lead 2 nitrates, 2 potassiums, 2 iodides. Keep this one together, 2 potassiums and 2 nitrates. Spectators, the K's go away and the nitrates go away. So our final answer is lead plus 2 iodides turns into PbI2. 2 plus, 2 minuses, it's neutral on the left side, neutral on the right side. Lead, 2 I's, we're good. That's going to get us full credit. For number 5, a saturated solution of strontium hydroxide. Okay, it's a solution. So since it's a solution, then we're going to write SROH taken twice, and it breaks up into ions. We have sodium sulfate. Sodium compounds are always soluble, so we're going to break that into ions. Switching partners, we have strontium sulfate, and we say, okay, sulfates are soluble except for CBS, and the S is strontium. And sodium hydroxide, all sodium compounds are soluble, so we get 2 sodiums and 2 hydroxides. Going back to look, we can see that our sodiums are spectators, our hydroxides are spectators, so the final answer is strontium plus sulfate turns into strontium sulfate. 2 plus, 2 minus, everything is balanced. We're going to get full credit on this. Number 6, sodium chromate, a solution of sodium chromate. So sodium is 1 plus, chromate is 2 minus, so Na2CrO4. Silver nitrate, Ag plus, NO3 minus. Now we're going to switch partners, and we know that the Ag is 1 plus, the chromate is 2 minus, so we need Ag2CrO4. And from our solubility rules, chromate is one of the ions that almost always turns into precipitates unless you have alkali metal. So the silver chromate would be a precipitate. And sodium nitrate, we know that sodium compounds and nitrate compounds are very soluble. Definitely going to break those up into ions. So we get sodium, 2 sodiums and a chromate. We get 2 silvers, 2 nitrates. We have the compound Ag2CrO4, 2 sodiums, 2 nitrates. Spectators, sodiums, the nitrates. So we have sodium plus chromate turns into sodium chromate, and don't forget that there are 2 silvers for every, I'm sorry, I'm saying it wrong. Silver plus chromate gives you silver chromate, and notice that we have 2, okay, and 2 over here to make all this work out. So we're going to get full credit on this one. Solution of sodium carbonate, so Na2CO3, and sodium compounds are soluble, so they break up into ions. Calcium nitrate, solution of calcium nitrate. Nitrates compounds are always soluble, so that's going to break up into ions. So notice we get 1 calcium, 2 nitrates, 2 sodiums, and 1 carbonate. Calcium carbonate. Carbonates are almost always insoluble unless you put them with an alkali metal, so calcium carbonate would be a nice precipitate. We keep it together. And again, here we have sodium and nitrate, definitely soluble. We get 2 sodiums, we get 2 nitrates. Spectators. Now notice if there's a precipitate and 2 ions, those ions are probably going to end up being spectator ions. So look for those first. So sodiums cancel out, nitrates cancel out. So here's our final answer. Calcium plus carbonate turns into calcium carbonate. It's the charges 2 plus, 2 minus on the left, neutral on the right. 1 calcium, 1 carbon, 3 oxygens. This is going to get us full credit. A saturated solution of barium hydroxide. Again, even though it's saturated, it is a solution. So we have barium hydroxide, and we have BaOH taken twice. But because we know that this is a solution, this is going to break up into ions. So we get barium and 2 hydroxides. Potassium sulfate. All potassium compounds are soluble, so we get 2 potassium ions and a sulfate. Barium sulfate. Sulfates are not usually soluble. They're usually soluble except for CBS, calcium, barium, and strontium, so this one's going to stay as a precipitate. And potassium compounds are soluble, so the 2 potassiums and 2 hydroxides. Again, we go through and say, here's potassium, here's hydroxide, here's potassium, here's hydroxide. Those are spectators. So our final answer is barium plus sulfate turns into barium sulfate. The charges balance, the atoms balance, we're getting full credit. Okay, our last problem. A solution of magnesium chloride, so Mg2 plus Cl1 minus, And we know that chlorides are soluble except for silver, lead, and mercurous. So these are breaking up into ions. 1 magnesium, 2 chlorides. Sodium hydroxide, sodium compounds are soluble, so we get 2 sodiums and 2 hydroxides. Hydroxides are usually not soluble, and magnesium hydroxide, only the alkali metal hydroxides are soluble. So this one stays together. And we have sodium chloride, and we know that sodium compounds are soluble, so 2 sodiums, 2 chlorides. Again, sodiums, spectator, chlorides, spectator. So we have magnesium plus 2 hydroxides turns into magnesium hydroxide, 2 plus, and we have 2 1 minuses, that balances out. The other side is neutral, so we're going to get full credit on this one as well. So that's how we do these kind of simple problems. So each one you want to get the ions, you want to make compounds, do a double replacement reaction, get rid of the spectators, and just practice this and get very good. Be sure again that you know your solubility rules, you know your ions, then you can do this. Also memorize which ones are strong and weak acids. All that stuff is on the Stuff I Should Know for the AP Test worksheet. So learn all this stuff and be ready for the test on May 6th.